In this video, we'll use the equations of motion of falling objects to solve a real-world problem. A person standing on a rooftop throws a ball straight up with an initial velocity of 15 meters per second. The ball does not hit the side of the building as it falls. Neglecting air resistance, calculate the position relative to the launch point and the velocity of the ball 1.5 seconds after it's released. To begin, let's list the known quantities. We calculate the position of the ball relative to the launch point. Therefore, we take the initial position, y0, to be 0 meters. We use positive and negative signs to indicate direction, with up being positive and down being negative. Since the ball is thrown upward, the initial velocity is positive, and its value is 15 meters per second. The acceleration due to gravity acts downward, so a is equal to minus g, which has a value of minus 9.81 meters per second squared. Finally, the time interval is 1.5 seconds. The unknowns are the position and the velocity of the ball 1.5 seconds after it's released. We start with the equation of motion that relates displacement to velocity and time under constant acceleration. Y equals y0 plus v0 times t plus 1/2 times a times t squared. Substituting the known values, we can calculate the position of the ball after 1.5 seconds. Evaluating this gives a position of 11.5 meters. Next, we use another equation of motion to find the velocity of the ball at time t, given by v0 plus at. Substituting the known values, we find that the velocity is 0.285 meters per second. Therefore, after 1.5 seconds, the ball is at a height of 11.5 meters above the launch point and has a velocity of 0.285 meters per second. Now let's look at a similar situation, but this time the ball is thrown downwards. A person standing on a rooftop throws a ball straight down with an initial velocity of 15 meters per second. The ball does not hit the side of the building as it falls. Neglecting air resistance, calculate the velocity of the ball when it's 5.5 meters below the starting point. As before, we start by listing what we know. We again set the initial position y0 to 0 meters. The final position y is below the starting point, so it's minus 5.5 meters. The initial velocity, v0, is minus 15 meters per second because the ball is thrown downwards. The acceleration due to gravity remains the same, minus 9.81 meters per second squared. We need to find the velocity of the ball when it's 5.5 meters below the launch point. We use the equation of motion that relates velocity to displacement under constant acceleration. V squared equals v0 squared plus 2a times y minus y0. Substituting the known values, we find that v squared equals 333 meters squared per second squared. Taking the square root, we get a velocity of 18.2 meters per second. Therefore, when the ball is 5.5 meters below the launch point, its velocity is 18.3 meters per second. This concludes the examples. Thanks for watching.